Thank you, everybody, for coming here today. My name's Tom. I'm going to show you a little about Sparkling Water, the 2.0 version preview. It's not officially released yet today, but what I'm going to show you are the next coming features that the team's been working on. And speaking of the team, this is the distributed Sparkling team. Normally, you'd actually have Mikhail up here talking to you, but he's in speaking of distributed, he is in China. He's in Shanghai today, so today you get me. We also have Kuba, who is a developer in the Czech Republic, and Mateus just joined us in Tokyo. So this is, I would say, by far our most distributed team at H2O. And it's a really, really neat result that we have here to show you and to talk about today. First, let me give you a little bit of background on what Sparkling Water is, for those of you that haven't heard about it. It's basically, the idea is to bring H2O's algorithms to the world of Spark users. And so the modeling algorithms available in H2O, since H2O is a Java project, it's open source, Spark is a Java JVM-based project, open source, it really makes sense to give you guys the ability to take those two worlds and use the best of both kind of side by side. And that's really with Sparkling Water what we're trying to do. And so in Sparkling Water, you can take a single Scala program, which I'll show an example of, just a quick piece of code, and you can actually have side by side in that same single stream, that same code stream, things that are doing Spark operations, things that are doing H2O operations. And here's an example. Here's a diagram of what the pre-2.0 world looks like, and the post-2.0 world also looks like this, but it has an additional option, which I'll talk about. And you can see there are Spark executors forming the actual workers, and in each of those executors, you've got an H2O block and a Spark block that can work side by side to do your machine learning and data munging. This is all driven by a driver program, that single Scala program or Python program. Or, as Mikhail showed in the last H2O open tour stop in Chicago, we now have the ability to, in the H2O Flow web UI, which I'll show you, have Scala code blocks, which is really neat. Flow is a workbook-based visual UI, which is really oriented towards data science users. So if you want to have the ability to be able to look at your data, browse your data, and look at model results in a very, very data science friendly way, Flow is a great way to do that. And here's an example of a piece of Scala code that you might write in Sparkling Water. And you can see there's two blocks here, and the upper block is focusing on a Spark operation, which is a Spark SQL join, and the bottom operation is a training of a deep learning model. And so data science folks, even though you want your work to be distributed, you want it to be parallel, you want it to be fast and scalable, you don't want to have to think complicated programming paradigms to get that. And so what we've done here is basically put the best of Spark and the best of H2O and let you easily access them both. So let's now take another step forward and talk about Sparkling Water 2.0 capabilities that are new. So what I'll show you here today is basically using a pure MLlib algorithm from Flow for the first time. So the algorithms that have been available from the web UI, the Flow web UI in the past have all been focused on things that were only part of H2O. But over the last couple of months, the team has spent some energy making those things in MLlib that are not available in H2O visible and accessible from the Flow web UI. So I'll show that. And then we'll talk a little about the HA improvements in Sparkling Water 2.0, which some customers have run into issues, especially on really, really large data sets where they had some problems. And so as a result of that, we took it upon ourselves to do a refactoring and a slight architecture change to improve the stability there, and I'll show you a picture of that as well. So the new changes to Flow that are really enabling you to call pure Spark MLlib algorithms directly take advantage of this REST API architecture that we've put in place. And basically, you can think of this layering that I've shown here as basically the algorithm implementation at the bottom with an adapter, a REST API adapter on top of that. And you could think of there being a facade on top of that. And so this facade is what Flow sees. And one of the things that Flow will ask the backend, and you can imagine Flow being in the web browser of the user here, you can imagine Flow, which is running in JavaScript, making a REST API call to the H2O, or in this case, the sparkling water backend, and asking, what algorithms do you have available for me to use? And what we've done is basically add a new one, which is SVM, and it's the SVM inside of MLlib. And the way we've done that is literally just by making the visual view that Flow, or the API view that Flow has, appear like it's part of H2O. Now, of course, what we've done is change the implementation of that adapter layer. That adapter, instead of going directly to H2O, now knows how to take that request, send it off to Spark, have the work be done, and then send back a response and tweak that JSON response so that Flow is able to see what it's expecting to see. And then the result of that is you're able to actually run an MLlib algorithm and take advantage of the Flow web UI. So with that, let me actually do that. So first, I'm going to start by running a new instance of Sparkling Water. And this is launching it locally on my laptop. This is going to just be a small, fast example. OK, and now H2O is up, Sparkling Water is up, Spark is up, and I'm going to connect to Flow in my browser. Let's make this a little bigger so it's readable. And another neat feature of Flow is you can store and reload flows. So I'm going to reload this SVM with cars example that I was working on earlier. And I'm going to just run it, and we'll let it run for a minute, and then I'll explain what it did. Here it's reading in the data. Let me just check to make sure my instance is up and actually working. Let me start it again, because I had a little bit of a network problem before. So let me just kick this off again. Come on, network. Well, it's being picky, so I'm going to show one that I ran before earlier. And here you can see the different cells in this diagram. The first cell is parsing the data, and here you can see basically you're able to preview the data set as you read it in. It gives you a preview of the first few rows and their data types. And once it's parsed in, you can get a breakdown of the data. It'll give you information about the column types, the min, the max, the mean, et cetera. And you can also see a distribution of the data and how big it is in the column compressed store in memory, and how many chunks there are on a per column basis. And chunks are what we in H2O use as the unit of data parallelism. So the more chunks you have, the more parallelism you can exploit. Most large data sets have plenty of them. And what's interesting here about this cell, this is a new capability that I talked about. This is a Scala cell inside the flow, the flow. And what that lets you do is it lets you embed Scala code directly here, which is really, really neat. So instead of having to be limited to only running stuff from, say, a script, you can actually embed stuff in a workflow here. And then this is the modeling step. And the actual SVM model finished in several seconds because it's a small one. And here we can see the output weights of our model in Flow. And so all of these modeling steps are being done in the backend by MLlib's Flow, by MLlib's core, but being exposed to the Sparkling Water user. And then finally, I will show you the Pojo. For those of you that are not familiar with H2O, and this is a little hard to read, I apologize, but for those of you that are not familiar with H2O, one of the really nice features about it is you can snapshot a model and export it as Java code. And so what we've done here is take the results of that MLlib algorithm and emit that to Java code, which we can then deploy in a number of different ways. And there's a talk later this afternoon about deployment. So stick around if that's an interesting topic for you guys. So in terms of the demo, that's the end of the demo. Let me go back to my slide. I've got a couple more slides, and I want to just show you the second part of Sparkling Water 2.0 that we're going to talk about. And this is the pre-2.0 picture. And here you can see the executor JVMs have Spark stuff and H2O stuff together in the same JVM. And some people have seen in their large data experiments that the Spark executors will disappear and come back, and that actually gives H2O trouble. H2O wants to have a persistent lifecycle, and the Spark lifecycle is a little bit different. So what we've done is actually have a mode in the next version of Sparkling Water where we can extract that H2O cluster out, start it early, have it be stable, and then have a little stub inside the Spark Executor JVM. And if those stubs come and go, it doesn't affect the stability of the H2O cluster. And so for those of you that have tried this on big data, like really, really big data, and had issues, this will fix that. So this is a new architecture feature in Sparkling Water 2.0, which will be based on top of an unreleased version of H2O. Or a not yet released, I should say. So the question is, when can I get this? And so because it's dependent on the Spark 2.0 release, which doesn't actually, hasn't come out yet, I can't actually give you a completely specific answer. But we're going to preview this on site with a customer August 1st, whether the Spark 2.0 stuff is actually released or not. So very, very soon, it's all in the top of tree, it's working, and we're ready to give it to somebody. If anybody's tried this on big data and had issues, I'd love to talk to you because we're looking to add more folks to our beta. And then the final thing I'll mention is the numbering scheme. Just kind of keep a little bit aware of the numbering scheme. So even though we're calling it Sparkling Water 2.0, the thing that I just showed you is actually built on top of Sparkling Water and Spark 1.6. So most of these things will be backported as well. So even though Spark 2.0 is the latest and greatest, and we're calling it that, really these capabilities are moving forward in the release chain for the different versions of Spark as well. That's all I had. Thank you for attending. Anybody have questions? I'd be happy to take them after. And I think we're up.
I was wondering if you could show the audience.
Just go. Back to my browser. Okay. Let me make this a little bit bigger. And sorry, my internet is a bit slow. My last demo was also struggling from that. Let me give it another shot. Otherwise, I'll have to reconfigure and maybe come back after the next talk. Yeah, sorry, I don't think it's going to work. So let me get my Wi-Fi in order, and then we can show that in an unscheduled slot. Thank you.